Hello, this is your Lakshma Reddy sir. Chemistry grand test for JE main. In our channel, it is grand test 4. A commercially sold concentrated HCl is 35% HCl by mass. With the density of the commercial acid is 1.46 gram per ml, the molarity of the solution is. For every question, I will give you 10 seconds time. Molarity is equals to percentage when it is given mass percentage into density into 10 by gram molecular weight. Direct formula you can apply. So 35 into 1.46 into 10 by 36.5 is 14. Remember, when density and mass percentage is given, density into mass percentage into 10 by gram molecular weight. An evacuated glass vessel weigh 40 grams when empty, 135 grams when filled with a liquid of density 0.95 gram per ml, and 40.5 grams when filled with an ideal gas. At 0.8 to 250 K, the molar mass of the gas. Good question. Think. Now you see, first 40 grams is vessel mass and 135 grams is when taken with a liquid. Okay, now so liquid mass how much it will become? 135 minus 40 is equals to 95 grams. And what is the density given? Density is equals to mass by volume. So volume is equals to mass by density. Mass is given 95, density is 0.95, which is equals to 100 ml. So volume is equals to 100 ml. Now what he is asking is the molar mass. PV is equals to nRT. N plus weight by molecular weight into RT. So molecular weight is equals to WRT by PV. Weight is given. Now you see 40 grams empty container, 40.5 grams when filled with a gas, means only 0.5 grams. R is equals to 0.082 given in the question. Temperature is 250 Kelvin given in the question. Pressure is given 0.82 given in the question. And volume is 100. So 0.0821, this 0, if you can cancel this can be cancelled. What is remaining? 25 into 0.5 by 100. This is in ml, means by 1000. So two zeros cancel, and this 0 will be cancelled. This 0.5, 5 into 25 is equals to 125. Good question. If the radius of the third Bohr's orbit of hydrogen atom is R3 and fourth orbit is R4, then think. R is equal to right 0.53 into n square by z. So for third 9, for fourth it will be 16 n square value. So simple. 16 R3 is equals to 9 R4. So R4 is equal to 16 by 3. So 16 by 9. 16 by 9. Consider the ions and molecules increasing bond order. This I will give you very simple. O2 plus means how many electrons? Oxygen means 16, plus means 15 electrons. O2 is 16 electrons. O2 minus is 17 electrons. O2 minus 2 is 18 electrons. For 14 electrons, bond order is 3. It is 2.5. This is 2. This is 1.5. This is 1. So what will be the best order? O2 plus IS, then O2, then O2 minus 2. Bond order shortcut is there. You can watch our videos. 8 electrons onwards. Bond order. If 8 is there, 0. 9, 0.5. 10, 1. Just increase 0.5. 11, 1.5. 12, 2. 13, 2.5. 14, 3. Now you decrease. 15 electrons, 2.5. 14 electrons, 16 electrons, 2. 17 electrons, 1.5. 18 electrons, 1. 19 electrons, 0.5. 20 electrons, 0. Just by seeing the number of electrons, you can say the bond order. The dE by dt different types of half cells are as follows, where E is the electromotive force. Which of the above half cells would be preferred to be used as reference electrode? To be used as reference electrode, the EMF change must be, electromotive force change must be minimum, and that you can notice here. Okay, now dE by dt, where E values are given, that is minimum in case of C. For standard reference electrode, the difference should be minimum. Choose the correct stability order of group 13 elements in their +1 oxidation state. For group 13, +1, +3 both are possible. Down the group, +1 stability increases and +3 stability decreases. So last element should have great, and that is thallium, first option. According to the Ellingham diagram, any metal oxide with higher delta G naught is more stable than the other one with lower. Higher delta G more stable means it is going wrong statement. Okay, now so this is wrong. The metal involved in the formation of oxide placed lower the Ellingham diagram can reduce the oxide definitely. This is right. In Ellingham diagram, if two lines are like this, up to this point, up to this temperature, this reaction takes place, down reaction. After this point, this reaction takes place, down reaction. So what we are saying, for example, this is magnesium and this is aluminium. Up to this point, magnesium oxide will become. After this point, aluminium oxide will become. Up to this point, magnesium reduce aluminium oxide. After this point, aluminium reduce magnesium oxide. Lower line is possible. Very, very interesting statement. Lower line is possible. Only one line you can get the complete. Lower line is possible. Okay, so 37. Statement 1 correct. So incorrect, and statement 2 is correct. Consider the following reaction: HSO4 minus and H plus, and you are getting here. After that, H2O2, this is 50% sulfuric acid. From that you will be getting the H2O2. H2O2 is asking about the angle. In the solid phase, the angle will be 90.2. Memory, NCERT. Hydrogen compounds. The correct order of melting points is: beryllium melting point is 1560 Kelvin. Magnesium is 924. Calcium is 1124. And strontium is 1062. So what should be the order? It should be started from beryllium, then go to calcium, then strontium, then magnesium. The correct order of melting points of hydrates of group 16 elements is: generally water melting point will be more, that is 0 degrees Celsius. All these will be In down the group increases, but water is the exception. Consider the following reactions. A plus alkali, B is the major product with pH bonds. So red phosphorus, pH3 plus H2PO2 minus. An oxo acid with no pH bond. H2PO2 minus is P double bond O H H O minus. Right? This is white phosphorus case. And he is asking about no pH bond. No pH bond means it happens with red phosphorus. He is asking no pH, but this is what I have written is for white pH. Red P for if you are taking with NaOH, it will be giving you H4P2O6. In H4P2O6, P double bond O, OH and OH. This is NCERT statement. Don't confuse. Red phosphorus will be giving you this one, and white phosphorus will be giving you H3PO2. Red phosphorus NCERT. Answer red phosphorus. Polar stratospheric clouds facilitate the formation of. Actually, here we use ClONO2. This will be giving you HOCl. ClONO2 will be giving you the formation of HOCl. Environmental chemistry, you can check. NCERT, again NCERT. In Lassen's test, when both nitrogen and sulfur are present in an organic compound, sodium thiocyanate is formed, right? NaSCN. If both nitrogen and sulfur are present in an organic compound, then the excess of sodium is used to decompose this one, right? NaSCN plus 2 sodium gives rise to Na2S plus NaCN. NCERT again. Both statements are right. Yes, you see free radical. Before this, what happened? What happened? This will be like this: C6H5 C double bond O Fischer cleavage C6H5 C double bond O with 1 electron. Okay, and later it comes like this. It will be forming C6H5 free radical. So option D, basic question. Now you see here, this is Grignard reagent. It is again Grignard reagent, and here C double bond O group is there. So what happens here? This minus charge. That's it. That part will be converted to alcohol. So 1, 2, 3, 4, 5. 5-member ring will be there. So this is not correct. 5-member ring. And the same carbon should contain CH3OH, CH3OH. Next carbon also should contain CH3OH. And between them, 1 carbon should be difference. Very simple. You write on paper, you will get it easily. Which of the following have highest enol content? Because this will be converted to OH, 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 aromatic stable. Maximum. By seeing this question, you have to say. See here, one C structure is missing. Actually, this is only answer. See, this structure I would like to give you. So the above part is same up to here. There is no change in this one. Okay, now. See, these two are same. OME is down and ME is down. Here ME is down, OME is up. So only difference is cis and trans. Now this nitrogen is attached. This carbon is this side it is attaching amine. After double bond OM is there. Here after double bond OM is there this side. And all this can be answered only on the basis of steric factor, and this is right. All these are enamines and are interconvertible because of resonance, and it must be answered only because of the steric factor. On the basis of steric factor, this is the best, most stable enamine formation. Which of the following sets are correct regarding polymers? Bunias is a copolymer because 1,3-butadiene and styrene, correct. Condensation polymer is nylon 6,6, this is also right. Nylon 6,6 is hexamethylene diamine and adipic acid, this is also right. Fiber, nylon is a fiber, 100%. Nylon 6,6 is definitely fiber. Then thermosetting polymer, terylene. Terylene is fiber, not thermosetting polymer. Okay, now it's a fiber. So this is wrong statement. And bunion rubber, bunion is a copolymer, not homopolymer. So this is again wrong. ABC correct. Polymers, easy question. A chemical which stimulates the secretion of pepsin is histamine. These kind of questions, if you know, you know. Otherwise, you can very safely say, very sorry here, because such questions you cannot. Completely memory based. 50th question. It is nitrate test. A dark brown ring is formed, right? Ring is formed due to nitro. See, nitro, so it is. A small difference, not nitro, nitroso. Nitro is NO2, nitroso is NO. Okay, this is nitroso. So, not true. This is your answer. For complete combustion of methanol, see, delta N is equals to 1 mole. This is liquid, don't consider. Liquid you don't consider, minus 3/2. So is equal to minus 1/2. Delta H is equal to delta E plus delta nRT. What is delta E given? Bomb calorimeter means delta E only. 726. Bomb calorimeter is always energy released, so minus 726. Plus delta N is minus 1/2. R value in kilojoules, na 8.3 into 10 to the power of minus 3 kilojoules. Temperature is given 27 means 300. When you solve this one, you will be getting minus 727.245. So round off. Nearest integer means already minus is given here, 727. You can answer. You have to check this question. A 0.5% solution of potassium chloride was found to freeze at minus 0.24. The percentage dissociation of sodium chloride. See, it is freezing at minus, so that means delta TF is minus 0. Plus 0.24 delta TF, because delta TF is equal to TF naught minus TF. TF naught is 0 degree Celsius, we know, minus of minus 0.24 means 0.24. This is delta TF value. And what we need to do? Delta TF is equal to I into KF into M. So 0.24 is equal to I value. Kf value is given how much? 1.8. What is molality? Molality is given 0.5. What is the molecular mass? 74.6 into 74.6 he has taken, you take. Okay, now you need to take the same value, 1000 by 100. If you go for this, I value you are getting 1.979. Once if you get one I value 1.979, alpha is equal to I minus 1 by n minus 1. 1.979 minus 1 means 0.979 by KCL dissociates into 2n, so n is equal to 2 minus 1 is 1 into 100 if you want percentage, that is 97.9 percentage, so 98. Answer 98. You can answer this question, but here the twist is 74.6 better. If you take 75 na the value, you will be getting 100%. So use what is given there. 50 ml of 0.1 acetic acid, 0.1 NaOH. When 25 ml of NaOH has been added, the pH of the solution is given. pK is 4.76. pH is equal to 4.76 pKa plus log of salt by acid. Okay, now both are having same concentration because you are given initially 50 ml and 0.1 ml NaOH is added 25 ml. So same concentrations are there. When 25 ml is added, so 25 into 0.1 m salt is formed, 25 into 0.1 m acid is left. So this is gone, log 1 is 0. So pH is equal to 4.76. He is asking into 10 to the power of minus 2. So the value is 476. The logic is very simple. When acid is equal to salt concentration, pH is equal to pK. You must answer this question. A flask is filled with equal moles of A and B. The half-lives of A and B are 100 seconds and 50 seconds respectively and are independent of initial concentration, the time required for the concentration of A to B. Independent of initial concentration means half-lives, that is first order reaction. See, A I am taking. After 100 seconds, if you are taking 100 grams of A for example, it will become 50 grams. One more 100 seconds, it will become 25 grams. Okay, now if I take same 100 grams of equal moles, 100 moles you say, not grams, moles. Okay, now moles only you take. 100 moles of B we are taking. After 50 seconds, how much it will become? Half. One more 50, 25. One more 50, 12.5. One more 50, 6.25. 6.25 and 25, these are 4 times you see. Got it? Got the logic? Okay, now after 100 seconds if you see, it will be 50 moles, it will be 25 moles, only 2 times. But after 200 seconds, it will be 4 times. In the same way, after 300 seconds, exactly, it will be, yes, 16 times, like that it will be increasing. And here it is 200 seconds. You can answer. 2 grams of hydrogen gas is adsorbed on 2.5 grams of platinum powder. The volume of the gas adsorbed per gram of the adsorbent is. Okay. If you are getting 2 grams on 2.5 grams, 1 gram gives how much? 2.5 grams, 2 grams of hydrogen. 1.1 gram, sorry, 1 gram gives how much? 1 into 2 by 2.5. Okay, so this will be 0.8 grams. 0.8 grams of hydrogen. What is asking? Volume. Volume is equal to nRT, 0.8 by 2 into 0.0821. Okay, now PV is equal to nRT. Temperature is given 300. Pressure is given 1 bar. 1 bar, 1 atmosphere, it won't make much difference. So So if you simplify this, you will be getting, according to my key, you will be getting here 9960. Check once. If you're not getting, complain me. Okay. The spin only magnetic momentum value of the most basic oxide. Lower oxidation state, most basic oxide. V2O3 means V plus 3 oxidation state. Vanadium 4s2 3d3 plus 3 means 2 electrons gone from here, 1 from here, so 3d2. 3d2 means 2 unpaired electrons. 2 unpaired electrons means it is 2.8 Bohr magnetons, or you say 2.9, nearest integer is 3. The spin only magnetic momentum, easy question actually. The spin only magnetic momentum value of an octahedral complex having upon which reaction gives AgNO3 2 moles of AgCl. See, here 4 ammonia is there. So 2 chlorines will be outside, only 1 chlorine. COCl2, 4 ammonia. Only 1 chlorine is outside. So it can give only 1 mole of AgCl. So this is not your option. PtCl4 2HCl. Platinum will be having either coordinate number 4 or 6. If it is 6, all chlorines are inside. If it is 4, then the problem. But he mentioned here octahedral complex, so all chlorines are inside. So this is your option, because it is Ni, H2O taken 6, both the chlorines are outside. So here nickel is in plus 2 oxidation state. Nickel plus 2 means 4s0 3d8. 3d8 means how many unpaired electrons? 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons, same concepts, same like above question. 2.8, you can take it as 3. On complete combustion of 0.3 grams of an organic compound gives 0.2 grams of carbon dioxide. Percentage of carbon is equal to mass of carbon dioxide by mass of organic compound into 12 by 44 into 100. Okay, now 0.2 grams of organic compound, 0.3 into 12 by 44 into 100. If you are solving this, you will be getting around 18. Compound P on nitration with dilute HNO3 yields two isomers A and B. These isomers can be separated by steam distillation. On dilute HNO3 means you are getting the nitro compounds. Steam distillation means these are ortho and para phenols. Ortho nitrophenol, para nitrophenol. And when treated with concentrated HNO3 gives C. C is, this is OH, NO2 here, NO2 here, NO2 here. So what is asking? Number of oxygen atoms. 2 here, 2 here, 2 here, 1 here. Total number of oxygen atoms are 7. Easy question. The number of oxygens present in a nucleotide formed from a base that is present only in RNA. Okay, now uracil is the base which is present in RNA, and he is asking when it is forming the nucleotide structure will be like this. O minus attached to phosphorus, it will be having double bond O, it is having O minus, and this is having again oxygen. See, this is phosphate which is linked to a furanose ring where OH is present here, OH is present here, H is present here, and this is attached to uracil, where uracil, it is a 6-member ring where this place is with double bond oxygen, nitrogen, double bond oxygen. Now tell me how many oxygens are there? What is asking? The number of oxygens present. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Tough only, typical only, because you cannot remember the structure. But one thing you can do, in phosphate you will be getting 4, not 4 actually, from phosphate 3, and this link, the overall link will be containing 4, and this is one furanose ring structure, the remaining 2. Okay, and then here 2. If you remember the uracil, then only it is possible. It's okay, chalega. So this is your lucky sir. It was grand test 4. We'll meet with grand test 5 and 6 like that. Okay, I'm explaining all this in detail. So learn like this. If you solve all these 10 15 grand tests, be sure you will be in NIT. Okay, damn sure.